Hey guys, welcome to day 70 of 100 Days of Code. Now, today is a crucial time point in our journey of learning to build websites because we're finally going to be publishing our Flask website onto the internet. And in order to do this, we're going to be using the help of a number of tools, including Git and GitHub, Heroku, and also something called G-Unicorn. And with their powers combined, we'll end up with our website being hosted live on the internet with a URL that we can share to anybody in the world, and they'll be able to go and access and use our blog website that we've spent so long building and perfecting. And you'll even be able to load it up on your phone and see it in its full glory. And along the way, we're going to learn about version control using a technology called Git. And also we're going to be upgrading our database from something that is more suited to development, which is SQLite. And we're going to be taking that to the next step, making it production ready using Postgres. So that's all yet to come. So if you head over to the next lesson, let's get started by learning about Git and version control. Now, before we can start deploying our website, the first thing we have to do and we have to understand is something called version control. And we're going to be using the most popular technology for version control, which is Git and GitHub. So let's talk about version control in its simplest form. Let's say that I create a new code file and I write a few lines in it. Now, I decide to put it under version control using Git, and let's say that I call this save point as number 1. Now, this is my first version. So later on, as I progress, I write maybe a few more lines of code. And at this point, I decide to make another save point, and I call this my second version. So further down the line, I accidentally screw up my entire code file and it's irreparable, and I get to the point where I would rather burn my entire code file rather than having to try and fix it. You do get into these situations because very often your code is interlinked and each class depends on another, and sometimes you can screw up in a way where, all hope is lost. And I simply just want to roll back to the last save point. I can do that using Git. I can do that using other tools as well, but the most popular tool and the one that we're going to be talking about is Git. So you can either compare your current code file, so the current mess that you've made, against a previous version, so at any of the save points before. Alternatively, you can simply just roll back to a previous version. And it doesn't have to be the one that was immediately previous. You can go as far back or as far forwards as you like, as long as you know which version you want. So that's the theory. And in order to put it into practice, let's see how we can create some files locally on our computer and put it under version control. Now, if you're on a Mac, Git is already pre-installed with every Mac operating system. But if you're on Windows, I want you to head over to gitforwindows.org and click download to download it to your system. Now, once you go through the wizard, you should end up with a folder called Git installed to your C drive under Program Files. So I can see it right here. Now inside this folder, you're going to open up an application called Git Bash. And this is where we're going to be executing all our commands. So notice how previously we talked about the terminal and how to use command line control of your computer. If you forgot about this, head back to day 54 where we covered this in detail. But in order to get started and to be on the same page as the video, I want you to go ahead and CD over to your home directory. So that's the tilde symbol. And once you're there, you should see this as your location. Now here, you're basically at the same level as being inside your C drive, inside users, and then under your current logged in users directory. So this folder and all the things that it contains, you can see are the same as all the things that are printed out when I hit ls at this location. So you're now ready to follow along with the video and start working with Git.
Now the first thing we're going to do is open up Terminal, and inside Terminal we're going to navigate to our desktop. So if you're not familiar with the command line and you haven't watched the module on the command line, then I recommend you to take a look at it now, because we're going to be using a lot of the commands to create directories and navigate around. So if you're not yet familiar, then it's a good time to take a look at that. So the first thing I'm going to do is I'm going to cd into my desktop. And here I'm going to create a new directory called story. Then I'm going to cd into this story directory. And if I show you with ls, you can see that it's completely empty. And similarly, inside Finder, I can show you the same thing. So let's go ahead and create some text files. So I'm going to use touch to create a file called chapter1.txt. And then I'm going to open chapter1.txt.
Now on Windows, instead of using open as the command, it's start. So you can write start chapter1.txt and that will open it inside Notepad. And you can continue following along with the video.
And it will open it inside the default application, which is TextEdit on a Mac. Alternatively, you can use a text editor within the terminal, for example, Vim. Now, this is only for people who are really familiar with this, so it's totally up to you what you decide to use. But if you are not familiar with using terminal-based editors, then it's probably a good idea to just stick with the open command and use TextEdit. So let's go ahead and open chapter 1, and let's write something inside, shall we? Okay, so there's my masterpiece done. I'm going to go ahead and hit save, and I'm going to quit TextEdit. So that was our first chapter done. So now let's create a Git local repository and start tracking some of these file changes. So to initialize Git, we simply write git init. And as you can see, it's initialized an empty Git repository inside the story directory. Now, if you have a look inside Finder, you actually can't see this .git at all. But as we learned before, if you use ls-a, you can see all the hidden files, and you can see that .git is right there. And it's going to be used to track all your changes, to commit your changes, and to perform version control. So we're currently inside the story directory, and you can also call this the working directory. So as I mentioned before, using Git and learning about version control, it comes with some of its own terminology and language. So I'm going to try and debunk and simplify a lot of these terms that you'll come across, just so that we can all be on the same page and we all understand what's going on. So currently we are inside the working directory, which is the story directory. And here, in order to start tracking the changes of my files, for example, chapter1.txt, then I need to add this file to what's called a staging area. And that is basically an intermediate place where you can pick and choose which files inside your working directory that you want to commit. So to see what's currently inside your staging area, you can use the git status command. And it shows you that there are untracked files which will be shown in red. And this is something that's simply inside your working directory, so inside here, but it's not yet in the staging area. So in order to add it to the staging area and to start tracking changes in it, then we have to use the command git add. So we're going to type git add, and we're going to type the file name. So in this case, it's chapter1.txt. So go ahead and hit enter. And then if we try using git status again, you can see that that file has been added as a new file and it is now green. So this is now in the staging area and it's ready to be committed. So let's go ahead and commit this under version control. So the command is git commit. And I'm going to use the -m flag to add a commit message. So the commit message is really, really important. It's something that helps you keep track of what changes you have made in each commit. So when you create a new save point, you want to be as explicit as possible about what changes were made between the last save point and this current save point. So for our initial commit, we can use something very simple like initial commit. And this shows that this is our starting point. Alternatively, if you want to be slightly more specific, because in our case, we've actually completed chapter 1. So you can write complete chapter 1. Now, the thing that you'll realize is that usually with commit messages, they are written in the present tense, and this is the best practice. So whereas it would probably make more sense, I guess at least in my head anyways, to write completed chapter 1 as this save point, it's actually by convention that you should always use the present tense. So it's like you are doing it now. You're submitting your changes now. So let's go ahead and hit enter to make our first commit. And you can see what commits you have made by using the git log command. So you can see that this commit was made at this time by this person. And it also has a hash. And this hash uniquely identifies this particular commit. And then right at the end, you see this commit message of what this save point was all about. So now I'm going to go ahead and create 2 more chapters. So let's just create chapter 2.text and chapter 3.text. And now we have 3 chapters, and I'm going to go in and change some of these text files. So let's say okay, so that's chapter 2 done. And finally, let's go ahead and just open chapter 3 and edit that as well. All right, so all 3 files have been changed, and over here in Finder, you can actually get a quick peek at what the contents are, which is going to be really useful for me to be able to demonstrate to you what Git is doing behind the background. So now let's go ahead and add these 2 new files to our staging area. So again, if we use git status, you can see that there's 2 files that are untracked, which are only in the working directory and not yet inside the staging area. So we can put it into the staging area by simply adding each of them as we did before, git add, and writing something like chapter 2.text and then doing git add chapter 3.text. But as you can imagine, if you have quite a few files, then it can get incredibly tedious having to do this one by one. So of course, there is a better way. So instead of adding these files one by one, we can actually simply just say git add and then use the dot to specify everything inside this current directory. So everything inside the story directory. So now if I go ahead and hit enter, and then let's go to git status again, you can see that there's 2 new files that have been added to the staging area. And now we're going to commit those 2 files to a new commit, to a new save point. And you know what to do. If you're following along with me, go ahead and give it a go. All right, so how was that? If you remember, the command is git commit, and we're going to use the M flag to specify a commit message, and we're going to write a message that is in the present tense. So let's say complete chapter 2 and 3. So that's everything I've done between the initial commit and this commit. The only difference is the fact that I've completed now chapter 2 and chapter 3. So let's go ahead and hit enter. So again, let's check it out using git log. We can see that we now have 2 commits, both with different hashes because they are unique and they are different. So the initial one was complete chapter 1 and it was done at this time. And then later on, about 5 minutes later, I completed chapter 2 and 3, and that was the second commit. And this is where we are at right now. So you can see by the head, by this word head, this is the position or the current state that we are in. So I just want to quickly recap what we've just done. So we created a file in our working directory inside our story directory. So the working directory is the folder or the directory where you initialize your Git repository. When we said git init, we did that inside the story directory. So that becomes our working directory. And from now on, Git is going to try and track the changes that it sees between the working directory and the local repository. So in the beginning, we created a file inside our working directory, inside story, and then we used git add to push it to the staging area. Now, the reason why there is this intermediate staging area, because you might wonder, why not just go from the working directory straight to the repository? Why do we need this extra step? Well, sometimes you might not want to add all of your files to be tracked or all of your files to be committed. So the staging area is a good place to try and figure out what are the things that you want Git to ignore and what are the things that you want to be tracked. So once we've used git add, we've put our file into the staging area and we're happy with the changes that we are going to commit, then the next step is to go ahead and commit it using the git commit command. So now our file is inside our local repository, so that .git, and that version is given a name through the commit message. So that means that even if we've messed up our file, we can still use the last version that's under version control, and we can use a special command called git checkout to revert back or roll back to the last position in our local repository. So let me show you what that looks like in the command line and how we would do that in practice. So at the moment, I've got 3 nicely written chapters, and I have a feeling my book is going to be a big seller. So now let's say that I have been working on chapter 3 and I have completely messed everything up and just, fell asleep on my keyboard. And I happen to have saved my file. And now if you have a look at it, it's now just mumbo jumbo and I've ruined my masterpiece. But fear not, because we have version control and we have Git enabled. So we have nothing to worry about. I can actually revert the changes that I've made locally in my working directory. So at this point, you can use git status to see that we have modifications in our chapter3.txt file that have not yet been committed or added to the staging area. So if we wanted to, we can actually revert this back to its previous glory. But before we do that, we can use a git command to check out what are the differences between the current version of chapter 3 and the last save point in our Git repository. So to do that, you can use the command git diff, so the difference, and we'll give it the chapter 3 file name. And if you hit enter, you can see that this is the part that was deleted, so the part in red. And then this was the part that was added, which is our gobbledygook. So now, if I've looked at these differences, it might just be that, there's only a few mistakes in my new version of chapter 3, and I just want to maybe copy some things over or have a look at how I did certain things previously and change my current file. But other times it might be that, it's just you want to torch the new file. You just don't want anything to do with it and you would much rather roll back to the previous version. So if you want to do that, then there is a command called git checkout that is going to be really, really useful for you. So git checkout, and then we're going to specify the name of the file that we want to check out, which is chapter3.txt. And if you just watch over here, which is the preview of the current version of chapter3.txt, once I hit enter on this command, that basically asks to roll back this chapter 3 to the last version that was committed in our local repository. So if I hit enter, you can see that almost immediately my chapter 3 has been restored to its previous glorious state. And this is the version of chapter 3 at the last checkpoint at which I committed it. So that was this one, which is completed chapter 2 and 3. So whereas in this lesson, we've looked mostly at local implementations of Git, so saving these versions on our computer locally, in the next lesson, I'm going to talk about GitHub and creating remote repositories. So I'll see you there. All right, so whereas in the last lesson, we were looking at local implementations of using Git and version control, in this lesson, we're going to talk about how you can create a remote repository. So a repository that's hosted on somebody else's server or somebody else's computer by using GitHub. Now, most people would have heard of GitHub. So if you haven't yet set up an account on GitHub, then this is the time to do it. So head over to github.com and simply fill out this quick form to create an account on GitHub. So it's completely free. And all you need to do is just confirm your email so that you can access it. Once you've done that, go ahead and sign in. So once you've signed in, you should be looking at this page. And what we're going to do is we're going to create a repository inside the browser-based GitHub. So if you navigate to this top right corner and click that plus arrow, then you can select New Repository. And I'm going to call my repository, same name, I guess we'll call it Story. And let's give it a description. Let's say my masterpiece. Now, by default, all repositories that you create on GitHub are public. That means that anyone can see all of the files inside your saved repository. So everything that you commit to your remote repository or to your GitHub repository will be public. So if you don't want that, then you can select private, which requires a subscription on GitHub. But in most cases, if you're not doing anything that's top secret, or if you're not developing technology that is completely brand new, then having a public repository is not such a big problem. And on the other hand as well, you can see loads of other people's public repositories, and you can see, for example, how they structure their code, what is their style, and you can see how people do things. So this is the beauty of open source code. And as you develop in your journey of becoming a developer, then you might find that you want to contribute to other open source projects, help them out a bit, and work in a virtual team to try and contribute your knowledge and your programming skills. Okay, so now once I've selected public, the next thing is that I'm going to leave this part empty. I'm not going to initialize a README for my repository just yet. So the next thing is that I'm going to go ahead and click the big green button and create my repository. So now you can see that there are two ways that they tell you you can set up your repository. You can either set it up in GitHub on desktop, their desktop client, which I am not a big fan of, but instead what we're going to do is we're going to use the command line instructions to set up our repository. So we are going to push an existing repository that we've got locally onto this remote repository. And to do that, we need to copy the address of our GitHub repository. And we're going to use these two lines of code in order to transfer or push our existing local repository from the command line. All right, so I'm currently inside my story directory, which also happens to be the working directory for this particular project. And here I am going to, again, take a look at git log to see what previous commits we've got. And you can see that we've got 2 previous commits, and I would like to push both of these commits onto GitHub. So to do that, the first thing is creating a remote. So it's telling my local Git repository that I've created a remote repository somewhere on the internet, and I want to transfer all of my commits over there. So the command that we're going to use is git remote add origin. Now, origin is simply the name of your remote, and you can theoretically call it anything you want. You can call it bacon if you want, but by convention, and it's highly recommended that you simply keep the name origin. And the reason is because most programmers are used to the conventional naming and that means it'll be much easier for them to understand what's going on in your project when they have a look at it, instead of you doing something completely different, which will be very surprising, and it'll be a lot harder for people to understand what's going on. So git remote add origin, and then we're going to paste the URL of our remote repository on GitHub, and then we're going to go ahead and hit enter. And now that remote is created, so we can push our local repository onto our remote repository, which is called origin. So we're going to say git push -u origin master. And what this line of code does is that it pushes your local repository to the remote repository using the U flag, or the U option, which basically links up your remote and your local repositories. And then we're going to push it towards the remote that's called origin, and we're going to push it to the branch that's called master. So the master branch is simply the default branch, or the main branch of all of your commits. So let's go ahead and hit enter. And there's going to be a little bit of work being done in the background, because it's actually going to have to upload your local repository to the remote repository on GitHub servers. And depending on the size of your local repository, this can take various amounts of time. So now, once we see our prompt, so the flashing cursor or the $, that means that our push is successful. And as you can see, it says branch master set up to track remote branch master from origin. Sounds really confusing, but if you head back over to GitHub, and if you're on the same page, all you have to do is hit Command R to refresh, or just press the refresh button. And you can see that all of our files are now hosted on GitHub, and it's complete with all of our commit messages. So if you go into Insights, Graphs, and go into Network, you can actually see our master branch, which currently only has 2 save points, or 2 commits. And if you hover over them, you can actually see the commit messages of each of these. So as you build out your project, as you add more commits, either locally or pushing it remotely, or probably doing both, then you can see the progress of your files in your GitHub repository. So now you can see all of the code, if it's code file, or in our case it's just a text file, hosted on GitHub, and you can point anybody towards this. And there are actually cases where people do a lot of story writing using GitHub, just because it's so good at tracking your save points and being able to revert to previous versions in the past. So for example, if you head over back to the main page and you go to your commits, you can see both of those commits, when they were committed, and also if you click on it, you can see the changes that were made at those time points. So if we have a look at chapter 1, you can see this is all we had at the point when we made our first commit. So previously we said that we have a working directory, which is the directory where we initialized Git. Then we can push our files to a staging area where we can pick and choose which files we want to commit. Then once we're ready, then we can commit our files, or our save point, to our local repository. So once you've done a few commits, then you actually have this timeline of various commits. And this is called your master branch. So the master branch is your main branch of commit or save points, and it is sequential, and this is usually where your main progress is saved or committed. Now later on, we then introduced this idea of the remote repository. The important thing to note is that you can have a local repository completely in parallel with a remote repository. Check the differences between them, but you can also sync them or push things from your local repository to your remote repository. So in our case, the local repository is the Git file that we've got inside our story directory, and the remote repository is GitHub, which hosts our code and also hosts all of the changes that were made in between the different commits. So we have this master branch of various commits, first commit, second commit, third commit, in our local Git repository. And when we performed the command git push, then that effectively pushed all of those commits, all of those various versions and changes and code pieces to our remote repository on GitHub. So that's what git push does.